For this example, I'd like to make a graph that satisfies all of the given conditions. So let's look at our given conditions. First row says my derivative at x equals 0, at x equals 2, and at x equals 4 all are 0. So that means at 0, 2, and 4 x values, I have critical points. So what I'm going to do is just going to go ahead and make an x and y axis, and I need to be concerned with the x values 0, 2, and 4. So again, there are going to be many different graphs that are all possible. However, all of them must have the exact same characteristics that I am about to display. So x equals 2, x equals 4 are important locations. And what I'm going to do is just put a little dashed line there. And I know that a critical point has to be somewhere on that dashed line. And at x equals 4 and on the y-axis. So on the y-axis and on those two green lines, I have to find a critical point that matches the rest of the conditions. So let's take a look at the next line. My derivative is positive if x is less than 0. Let's think about what that means. My derivative is positive means my function is increasing because my instantaneous rate of change is positive if x is less than 0. So somehow my function's going up more or less over here. Now it's not straight, but I'm just showing it going up. Now, next line, or the x value is in between 2 and 4. So in between 2 and 4, somehow my function has to be going up. And again, we don't know where it is, but somehow it's going up in between there. My first derivative, third line, my first derivative is negative if you are in between 0 and 2. So somewhere in here it's going down. And it's negative if x is larger than 4. It's going down. Okay. So that helps me out quite a bit. Last part is my function's second derivative is positive if x is between 1 and 3. Okay, so let's talk about that between 1 and 3. And I'm going to put that as a red dash. X equals 1. X equals 3. These are called inflection points when my second derivative hits 0, and it looks like it's going to hit 0 around 1 and 3. It doesn't say it explicitly, however, if you notice, it's positive between 1 and 3, and it's negative outside of 1 and 3. So those are going to be my critical points. From here, I've got some good insight. I'm going to go ahead and make a graph now that has all those characteristics. Here's a critical point, and the function is increasing everywhere else. Now, I have another critical point at x equals 2, which must be a local minimum because my function's going down to it and it's going up after it. There's an inflection point at x equals 1 somewhere in the middle, so I'm going down, just making a rough graph, and I reach my steepest somewhere around x equals 1, and then I start to concave up. And at exactly x equals 2, I reach my minimum. And again, what's important to know is this graph can shift up or down. And then I'm curving up. So my function is increasing, curving up until I hit x equals 3, where I have my second inflection point, and then the function must start to concave down, and will continue to concave down until it hits its maximum, local maximum, at x equals 4, and then it'll continue to concave down afterwards. So this is just one possible graph. When I say one possible graph, what else could the graph look like? I shall show you. We don't know whether any of the y values are positive or negative, so this graph here would also work. Because it meets all of the key characteristics. Maybe a little bit over here is a little bit rough. Okay, key characteristics, critical point, critical point, critical point. Other key characteristics, inflection point, inflection point. So the function can shift up or down. Your local min can be a little lower or a little higher. Your local maximums can be a little lower, a little higher. However, they must occur at 0, 2, and 4. They have to. Your local mins and max must occur at 0, 2, and 4. And your critical points, your inflection points must occur at x equals 1 and x equals 3. So again, I'm just taking the information given and making a possible graph. In this case, I've made two possible graphs that both satisfy all of the required information.